Ha, kids. Okay, I'm going to talk to you a little bit, to at least give you a little instructional video about diffraction. Okay, so remember, diffraction is just how light bends around corners. Or actually any wave bends around corners. A good example of this would be, if you are, here's a building, here's the corner of a building, here's you, here's your friend. If you're talking, your friend can hear you. Why can they hear you? Because the sound wave bends around the corner. It's diffraction. That's what diffraction is. But a lot of times, if we're talking about light, for example, we'll do things like this, where we'll say, hey, if I have waves approaching like this, and it hits this little slit, okay, that, remember, each one of these points on the wave will act like a point source. So you can think like, this is going to be going out, this is going to be going out, this is going out, going out, going out, and when they interfere, you get that wavefront again. Well, if that hits right here, then guess what? What's going to happen? It's going to go out like this, okay? And again, the reason why, according to Huygens' principle, every point along the wavefront acts as a point source. Okay, so there's that. The other thing to keep in mind, guys, for diffraction to occur, the slit width has to be right about the same size as the wavelength. Obviously, it can't be much bigger. It can't be teeny tiny, and it's got to be right about the same. For diffraction to occur, the slit width must be about the same size as the wavelength of the waves. Okay, so as long as this slit here is on the order of the same size as the wavelength of the waves, you're going to get a lot of refraction. If you don't, for example, if it's kind of big and fat like this, then you're going to get diffraction at the edges, and then it's going to be pretty straight. Okay, so like this part, really no diffraction, and then on the edges, because again, every point acts like a point source. So there is basic stuff with diffraction. Bye, kids.